So for today, my goal is to cover some examples with talking about loops or working with loops and giving you some examples. And maybe we can talk about assignment 6 and also cover what will be on the midterm. I guess I need to link assignment 6 here, but so let's look through the examples first. I would encourage you guys to download these locally so you can follow along. So the loop examples are on the website. So these are all out of your text. So I want to look at these 7 or 8 examples in the order that I'm showing these in, and so I guess we don't have textpad here, so we'll use Notepad, I guess. These are all, of course, can be executed as well. What I'm going to do is look at the code and show you, basically cover what the program does. The idea is to give you exposure with loops. That's the bottom line. Coding is, of course, best learned with, looking at examples and following along. So in this particular example, we are trying to figure out tuition. If it increases at a rate of 5% per year, right? So we often get into these quandaries where what will the tuition be in 10 years if I was going through my undergrad or degree programs? So let me do this just to make life fun. We'll also run these because I think that will probably add more value than just staring at the code here, right? So while Eclipse comes up, we have tuition is set to $1,000 and count is initialized to 1. And I have a while loop, and I'm basically saying while count is less than 10, meaning for the next 10 years, let's see when we add a factor of 5% to the tuition, what happens? What will the tuition be in 10 years with an increase of 5%? And then we are doing something here. And maybe you guys can help me with reading the second part of the code, right? So here, let me see if I have a program already set up. So I have this program called Hello2, and I guess I'll just use that. And what I'm going to do is just copy and paste things in main. So I'm looking at program 5.7 from the website. Okay. So let's run this. You can kind of see what's going on here. it's telling me that tuition in 10 years will be $16,000 a year, almost, if I increased it at 5% per year, right? So actually, I think I'm interested in 8 years because my son will be in college by then. And so in 8 years, it'll be 14,000, well, almost, yeah, 14,000. So now we have tuition in 10 years, but what will the 4-year tuition cost me? We have double sum equals tuition. So tuition is already calculated and that's the value. So that's the value for the first year, right? Now what happens is every year tuition continues to go up by 5%, right? So I can't just say this big old number times 4, because if the rate of increase of tuition is constant, I'm going to multiply that by 5 and then add it to the sum, right? So assuming in today's dollars, 8 years from now, which was the calculation I started with here, I can't say 10 years, I guess. Let me leave it to 10 so the value is accurate, right? The value in 10 years would cost $70,000 for an undergrad. Is it 10 grand a year these days? It's more. Well, I just want to dream with these numbers for now, just to keep things low, right? Okay, so let's look at the next example. Are these examples, useful? They'll give you a lot of things to work with as far as a lot of good references here. Okay, so our next one. This is actually a little bit of fun, I guess. So this program is printing some patterns. We're using a nested for loop here. So here we are saying we go from I will go from 1 to 6, and J will go from, J is another variable, and will go from 6 to 1. Because it's greater than equal to 1, right? So you can write loops so the loops increment. You can also write loops so the loops decrement. And it says, this is a new thing that you're looking at. It says, if as long as J is less than I, so this is another way of writing in its statement. It's kind of a little shorthand. So the system.out.println. So it's going to print the value of j plus. So this will print the value of j plus. Just print two statements. Like a shorthand for an if statement. The question mark, when you say question mark, that means this is the if part. Okay? And this is if the condition is true, then do this. If the condition is false, then do this. So this statement is the same as this. Is that pretty clear for everyone? Right? And it says I have errors. How do I have errors? Begin, end. What's this problem? Oh, I have a loop. Aha, okay. That is for the for loop. This is right triangle in numbers. All right. So it's a good idea to get into the habit of reading a ton of code. One of the things about learning language, programming languages, is reading a ton of code before writing. And mastery to this can happen with examples. So in this case, folks, we are using a nested for loop. How many times is this loop executing in your opinion? How many times is the outer loop executing? Let's just talk about that first. 6 times. What about the inner loop? How many times is that executing? If you're focusing on any other things right now, my suggestion is play with me. Wait. Okay? This is for you guys. So forget about anything else you're working on right now. So how many times will that execute? 6 times. Greater than equal to 1, right? So 6 to 1 will be 6 times inclusive. Very good. So when we have a nested loop like this, it executes how many times? 36 times. For every value of I being 1, j will go from 6 to 1. Okay? Now look at the picture in the bottom. Look at the output. And please tell me if this particular horizontal line to print the value of 1, is that controlled by inner loop or outer loop? So this is the inner loop. What prints the value of 1? Is it I or j that I'm printing out? Because my action, right? If you look at this code snippet, that's a condition. And it says j is less than equal to I. So j will be less than equal to I only when I is I is equal, because we're only printing 1, right? So, and plus look at it here, this is what we are printing. We're printing j and a space. So we're printing the value of j, not I. And this printout is controlled by the inner loop. Okay? Now there is also something called debugging. I want to talk a little bit about that. You can running programs like this is nice. So you can see the output. But what happens as you step through the code and you want to see what's going on, right? That process is called debugging. How does debugging work? So to use the debuggers here, so let's say I'm most interested in this print line, okay? So I can right click on this side and I should be able to click here and add a breakpoint, right there. You see that little colorful thing, right? On that little scroll bar or whatever it is, that's a breakpoint. So by clicking on that line, I'm basically saying I want the code to stop there because I want to see what's going on, right? So I'm going to go into project or run and I'm going to debug this. I can also hit F11. When I click on debug, it says blah, 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 just say yes. And that's what I get. You see, I've got a bunch of things here. First of all, it's telling me which part of the code it's running. If I look at these things on the top right, it's telling me the value of variables as I'm going through this loop. And you see the code has stopped there because this highlighted line tells me what? That's the line that I've executed the first 2 lines and I've stopped at this line, right? So, and plus you can see the values here. The value of I and j. Can you see that in the back? Or is it a little teeny tiny? I know that. I know. But we have the value of I is 1 and j is 6, right? So now I'm going to go into run and I'm going to step over F6. I'm going to keep hitting F6 and I just want you guys to see how this for loop is operating. It's really cool because you'll see exactly how this nested loop works. And keep an eye on the value of I and j. You see, we just started the loop and j is 6 and the value of I is 1. Yeah? So I hit F6 and it goes back to the for loop on the top and it decrements j by 1. Now j is 5, right? That value changed. And what is he going to print? 5 is less than equal to I. 5 is less than equal to 1? No. So he's going to print double space, right? Now it's 4, 3, 2, and 1. And when the value of I and j is equal to 1, that's when I get a 1 down here, right? Stepping through the code line-wise to figure out what's going on. Now that I'm done with the inner loop, it goes out and does a print line, right? So now the reason it did a print line is because we want to now look at the next line. So now what happens to I? I becomes true, right? It'll be kind of boring to run through this a couple of times, or shall I keep going? Are you guys getting the concept of debugging? Okay. So now I will go from 6 to 5 to 4 to 3 to 1. And look at that, it prints 2 and 1 in the bottom. And we are using nested for loop. So when we do a print line, we've got the next line done, the fourth line, the fifth line, and finally, I went through it really quickly. But the point is that I can watch the value of variables, okay? I can step through the code and see what's going on. Now, if it turns out that if I didn't have this, I can still mouse over a variable and see what the values would be, or I can do print lines. But print lines are kind of boring, right? Because that's extra work you have to do. So looking at variables here becomes a good idea. I can also see a list of my breakpoints. Right now it's telling me it's at line 8. If I don't want the breakpoint, I can either disable it or remove it. So when you're running your code in debug mode, you're stepping through it line by line, and the interface looks different. The look and feel on Eclipse is in debug mode right now. When I want to stop debugging, I can simply say run terminate or control F2. And when I terminate, now the program has stopped. I can go back to my regular mode and run. Okay? We're going to please try out debugging today. Add a breakpoint, check out the values of some variables, and step through the code. Try this out because this is a handy tool for a developer. Okay? And you must know this really well so you can troubleshoot issues. The other thing is if you're trying to understand the concept and you don't, if you can't figure out, hey, how does a nested for loop work? Now you can step through it line by line and have your aha moments right there. You can see what the program is doing. And that also helps with creating algorithms. Okay? It also helps in fixing logical issues in your code. If 2 plus 2 becomes 5 for some reason in your program, I'm just taking a simple example, but trying to make a point that if something is wrong with your program and you need to figure out what line number is causing the issue, this is kind of a simple way of just stepping through the thing and finding the problem. Yes? Making sense? Some feedback? Yes or no, right? Even if you don't want to talk, just nod your head one way or the other. Please. I'll show it during so the way to get into debug mode is run and then click on debug, right? And it is important that you first add a breakpoint. If you don't have a breakpoint when you say run debug, it runs to the end of the program. You don't want that. Maybe that's why it's not working, but I can help you guys one-on-one, later on. We'll try this exercise, right? Okay. I have more programs. The next program. So this is kind of nice. Actually, you know what? Let's run it, and then we can look at the code because after running the code will make sense. What this program does, it says enter the loan amount, for example. Guys, start focusing on user-friendly commands for input. If you keep saying enter a value, what data type? You want me to type in a float, an integer, a string, what? Let's talk about user-friendliness, right? Your program should be user-friendly. So I want to enter a loan amount, so $1,000 for simple math. Enter number of years as an integer, for example, 5. Okay, 5. Wow. It prints out this little chart. It says that at an interest rate of 5%, my monthly payment will be $18, and total of payments for over 5 years will be that. See, that's a nice little chart to have. And it comes out of for loops, right? I think I want to do something real, like, okay, let's get a loan for like $1.4 million over 30 years. My monthly payment will be $7,500, and this is how you run the mortgage companies, right? Mortgage company is going to make $2.7 million on a $1.4 million loan over 30 years. That doesn't sound right, actually. They should make a lot more. This is simple interest, right? There is simple interest and compound interest. So, okay. Let's look at the code. What does the code look like? How does this actually work? So it reads the input, right? Now this is a pretty good standard for organizing your input. Anytime you use a scanner, put a print statement or a print test statement on top, telling the user what you're expecting. That's a good programming habit. Enter the number in years. So then we display the header. Display the header, like what is the interest rate, monthly payment, and total payment, which is this guy right here. That's being printed. Then we have a for loop, and we say for decide the annual interest rate to 5%, and as long as annual interest rate is less than equal to 8, increment the annual interest rate by an eighth of a percent. So that's why you see 5.0, 5.125, and so on, right? It computes the monthly payment to print that, and also total payment. So it's doing the total payment for the term of the loan. And then it uses a printf to print out those values. So another example of usage of for loop, right? So, and it incorporates number of years. We could also go back and rewrite a program and say, over the life of the loan, how much money will I end up paying? Okay? And we can try to do a printout by year. So loan calculators are right, as you can see, and it also uses loops. So if your date of birth follows is on February 29th, right? You celebrate it every what? 4 years? If that happens to anyone, right? Here is a formula, and here's a formula for figuring out if a year is a leap year. Got a begin and that, and we've got this as 0. program is printing out all the years that are leap years between 101 and 2100. I guess I don't care about 101 so much. Maybe we should start with what? All the way to 2100. All these years are leap years. So look at this code and tell me what's the definition of a leap year. So here is a leap year if it's divisible by 4 and not by 100, but by 400. What? Did that make sense? So if a year is like, so just to show the value, if I say 396 and 410, right? The year 400 is a leap year because it's divisible by 400. But folks, if I make this 296, right? The year 300, I can make this to 396 to 310. The year 300 is not a leap year. I mean, if I was there around at that time, I would know. I wasn't though. So what is a leap year? A year that is divisible by 4, not by 100. So this is an AND condition, and also divisible by 4. Okay? Fellows, are you all with me? Yes? Because the year 300 is not a leap year by definition of Gregorian's calendar. I'm not sure if it's Gregorian's calendar or Julian's, but it's just by definition. And we are just, you know, if you go and look up Wikipedia on Julian's calendar or Gregorian's calendar, it will define the definition. It will give you the definition of a leap year. And we're just coding now. That's the only exception. So if you wanted to see all the years and do some analysis of your own, you've got plenty to look at here. The year 400 is there. Is 500 there? No. The next one is 800. Okay. So, all right. So this is another simple for loop. Now this is an example that I would more or less ask you to code in my. Well, maybe I should ask you to code it here. So I'm going to try and do something here with the calendar. So I'm going to say 2015 enter the first day of the year. What does that mean? First day of the year should be a 0. It will be 1. But I think what it's asking is, was it a Monday or a Tuesday or something, right? So let me enter 1 and see what happens. January 1st, 2015 is a Monday. Is that true?
No. So if I had entered 5, so what this is doing is it's computing the first day of every month in that year, knowing the first day of the year. That's what this program is doing. It's going through a loop to do this, right? So if I say 5, Jan 1st becomes a Friday. That's wrong too, right? It was a Thursday, so I should enter 4. So sometimes software is written and it doesn't tell you what to do, so you have to kind of figure it out, right? That's not super software. So enter the first day of the year, okay, 4. So finally, is February 1st a Sunday? March 1st a Sunday? April 1st? Wednesday? Okay, so now we're fine. So this code is implementing some algorithms. And if you guys have some extra time in your hand, I would recommend going through this. So you say enter a year, enter the first day, and then for the 12 months, it will figure out the number of days in the month using a case statement. Are you guys familiar with the switch statement? And you see it uses that leap year definition to figure out if the year will have 29 days or 28 days. Okay? And then it will print out based on the calculation of the first day, if it's a Sunday, Monday, or whatever. The first day value changes in the end here based on the number of days in the month. So the fact that you can do this in a loop for any year, right, all of a sudden gives you the capability of creating a full calendar. Okay? Please take some time to review this code. This is example number, these are examples from your text actually, 528. It's exercise 528. So the next one we have is exercise 529. It's on the similar line. And if I run this program, guys, I guess I managed to create errors. Did I not copy the scanner? Okay. I'm the wrong program here. I'm supposed to be on 520. Okay. Here, I take the first day of the year, and it prints out
So this is yet another so this is using nested for loops. So this one is a little bit complicated. And let's try to understand this code at a high level. So we say enter a year, enter the first day, so far so good. Then it has this outer loop. So this outer loop is going from month January through December, right? So this is the outermost loop. We then go out and print the title and also figure out the number of days in the month. So the code that was in the previous example is reused here. Okay? Figure out the number of days, and then there is a nested for loop. There's a nested for loop to print out the number of days in the month. Okay? And it actually, this code prints out. First one prints out the number of spaces. So the code that is highlighted prints all of this out. You saw an example of that a little bit earlier, right? And then we have I is less than number of days, and we print the value of I, and then add a carriage return. So this for loop is inside that outer for. And there are good comments. This one gets the start date for the next month. So this particular line basically gets us from 31 to the first, because we need to keep our printout, our printing between, these limited number of spaces. Another example of loops. I think I have 3 more examples to show you guys. So this one is doing conversion from base 2 to base 10. You guys learned that in the beginning, right? So here we are, enter a value like or if I were to look at a value like 2, binary representation is 10. How does this work? Well, the code is actually in front of you, and it's very simple. So we are trying to build a string, and we say the value that we read in, we save it into, we save the value into decimal first, and then we use value, and we say, while value is not 0, let's divide it by 2, and start building the binary string. So binary string is empty in the beginning, but what we are doing is taking the remainder every time and adding it, and we keep dividing it until the value becomes 0. So base 10 to base 2 conversion, you can take a large value, right? So this is something that you can use for building a calculator. Base 10 to base 2 conversion. So this is on sales and commissions, and this is on heads and tails.
Actually, let's take a look at this program. This one is a little bit interesting. $100,000 times. And this program randomly figures out heads or tails. Okay? We have a function called maths.random that we use. It generates a random number. So whatever number it generates, I multiply that by 100,000, and I take a modulus. I use modulus 2. Are you guys familiar with this operator? Percent? Like 5% 2 is what? 1. 4% 2 is 0. So basically looking at the remainder. So we are going through this loop 100,000 times, and we are trying to figure out if the toss is a 0 or a 1, and based on that we say it's either heads or tails. Okay, and we print out the final value. So these are all the programs I have on loops for you guys. These are uploaded, and these are useful because it gives you plenty to refer to for the lab assignment. Okay? So the next thing I'm going to do is work on assignment 6. So let's take a short breather, like 10 minutes, and we'll continue.